Welcome to our discussions and thank you for always joining us. We are presenting a question that was done in KCSE 1993, paper 1, question number 20. The question we have reads, on the grid provided, plot a graph of y is equal to negative 2x squared plus 3x plus 6 for the range of values of x between negative 3 and positive 4. Then use your graph to estimate the roots of the equation. Negative 2x squared plus x plus 9 is equal to 0. What we are going to do, I'm going to start by again getting the turning point of the curve before I draw a table. We know the function given is y is equals to negative 2x squared plus 3x plus 6. And for us to get the turning point, I know at the turning point of a curve, the dy over dx, as we have mentioned previously, is equal to 0. Meaning if you differentiate this given function here, whatever you get, you equate it to 0. For the differential function of negative 2x squared, you get negative 4x plus 3, and this one will be equal to 0, meaning negative 4x is going to be equal to negative 3, meaning if you divide both sides by negative 4, x is going to be equal to positive 0.75. Once you have the value of x, we usually substitute it in the function y so that we can get the y coordinate. In this case, we are going to have negative 2 multiplied by 0.75 squared plus 3 times x, which is 0.75 plus 6 plus 6, and this one is going to give us, that is 0.75, and this one is going to give us the value equivalent to 7.125. Therefore, our turning point is going to be 0.75 and 7.125. It is not a must for a student to show the working, but at least that point must be plotted on the graph for a person or for a learner to earn marks from that particular point. From here now, we are going to make a table having the values of x and y. The values of x are ranging between negative 3 to positive 4. So we begin with negative 3, negative 4, that is negative 3, then negative 2, negative 1, then 0. Before we go to 1, we have 0.75 as the turning point, and 7.125. From there we go to 1, 2, we go to 3, and lastly we stop at 4. From here now we can be able to use the values of x to get the values of y. The value of y when x is negative 3 will be negative 21, and the value of y when x is negative 2 will be negative 8. When x is negative 1, the value of y is 1. When it is 0, it is positive 6. When it is 0.75, it is 7.125. And when it is 1, it is 7. When it is 2, you get 4. When x is 3, you get negative 3. And when it is 4, you get negative 14. Having done that, we can now move to our graph and draw the graph. Looking at the highest value for y, which is negative 21, that means the lower part is going to occupy most of the graph, and therefore we are going to simply move up here. That is where our graph is going to begin from. So assuming this is our point of origin, then we are going to have -1 here, -2, -3, -4, then 1, 2, 3, 4, and even 5. This is our x-axis. Then the y-axis, since the highest value is -21, we are going to use a scale of 1 centimeter to represent 5 units, that is -5. Then we have -10, we have -15, then here we are going to have -20, and probably we have -25, so that we can accommodate 21. Then upwards we are going to have 5, 10, 15 there. This is going to be our y-axis. From there, our scale for x-axis. For x-axis, we have taken 1 centimeter to represent 0.1 units. That is to represent 1 unit, to represent 1 unit. And on the y-axis, we have said 1 centimeter to represent 5 units. Having quoted our scale, we can now go down and do the plotting. When x is -3, y is -21, -3, -21 is down here. That is for -3, sorry. -21 is here. And when x is -2, -8, -2, -8 is here. When x is -1, -1 is 1. This is the point, because we have 5 small units within one box, each 1 unit. And when it is 0, it is 6. 6 is exactly at this point. When x is 0.75, 0.75 is around this point here. The value of x where the curve is turning is 7.125. This is 6. Then 7. 7.5 is here. Let me use a cross to show that this is our turning point. And when x is 1, it is 7. When x is 1, it is 7 here. When x is 2, it is 4. 2, it is 4 at this point here. And when x is 3, it is -3 at this particular point here. And when x is 4, it is -14. -14 is at this particular point here. Now we can join all the points that we have plotted for us to get our curve. So we are going to have to join all the points. Once you have joined all the plotted points, you can now name your curve as y being equal to -2x squared plus, we have 3x plus 6 Most of the students again lose marks here because of failing to label their graphs. And lastly, we are moving now to the last part where we are supposed to use the main function, which is, let me call this part B. Y is going to be negative 2x squared plus 3x plus 6. We are supposed to use that main function to work out negative 2x squared. Negative 2x squared minus, that is plus x minus 9. And this one is going to give us, we usually subtract the 2. When you subtract the 2, we are going to have negative 2x squared minus minus, which is going to cancel. And this one is usually equal to 0, such that y minus 0, you get y, which is going to be equal to 3x minus x, you get 2x, and 6 minus 9, you get 15. Once we have this, we are now going to have our table having the values of x and y. And remember, the values that we are going to take should be the values that are going to be represented in our table or in our graph. So in this regard, we can assume the value of x to be negative 2. If we assume the value of x is negative 2, the value of y is going to be negative 4 plus 15, which is 11. And if we assume the value of x to be negative, to be around negative 4, to be negative 4, then the value to be negative 4, the value of y is going to be negative 8, which is now negative 8 plus 15 is going to be positive 7. These 2 points are enough for us to plot our graph. So we are going to proceed. When x is negative 2, y is 11. Negative 2, y is 11 at this particular point here. And when the value of x is negative 4, when x is negative 4, the value of y is going to be positive 7. Negative 4, we are going to have positive 7. And the positive 7 is around this point here. From here now we can be able to draw negative 2, 11. Yes. And of course, negative 4. Negative 4 is not here. Negative 4 is here. The other one is going to be 7. Negative 4 here. This is going to be 7. At this point is where we have 7. And there is no point at which this particular function is going to be okay. Let us try to correct the mistake. No, there is a mistake here, because from this table here, you realize that this operation here is not correct. That means whenever you subtract these two, we are going to have y being equal to 2x minus 3, because this is plus 9. From there now we are going to make a table having x and y. From here we are going to have 0. The y is going to be negative 3. 2 is going to give us 1. And this is what we are going to use to draw our point. When x is 0, y is negative 3 here. And when the value of y is 2, x is 1. 2x is 1 at this point. Now we can join the 2 points. So from here we can be able to pick the values of x at the point where the two curves intersect. X is going to be equal to around negative 1.9. and the other value of x is going to be around 2.15. Thank you for watching.